Okay, so now we're going to learn how to solve a system of linear equations by using the addition method. Now, when given a system, you want to determine what would be more strategic, either using the substitution or the addition method. So, for example, in the problem we did in part 2, you see how one of the equations already had a variable by itself? Then using a substitution method would be the best thing to do. Using substitution would be the easiest. So substitution gives it to you quick. Um, so use substitution, like in number 2, I would have used substitution here because one of the variables is already by itself. It's already been isolated. All right, so use substitution there. If one of the variables is not by itself, it really does not matter which approach you take, either substitution or using the addition method. But most students prefer using addition method in situations like this. Okay, so just using addition method. All right, so basically the idea behind the addition method is this. At some point, you're going to be adding those two equations together. So you can be combining like terms. And you want one of the variables to disappear. You want one of the variables to be eliminated. So for example, if I add those two right off the bat, if I go and add them now, x plus x is 2x. So if I add these, x plus x is 2x. A positive y and a negative y is 0. So the variable y is eliminated. Equal, and then 1 plus 3 is 4. And so notice I end up with the equation with just one variable. Just like when you solved a system using substitution, you ended up with an equation with just one variable, and you solved for x, and then you did all the rest of the work. And that's what's going to happen with addition method as well. So you ended up with an equation with just one variable. So I end up with an equation with just one variable, and I solve for x. So you solve. So you can divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. I get x to be 4 divided by 2, which is 2. So far I've found that my solution to the system, x has to equal 2. That's what I found. Now remember, just like with substitution, once you found the value of x, you just went back and you back substitute to find the value of y. Same thing here. Once you find the value of x, you go back to one of these equations to find the value of y. So watch what happens. So there's a lot of similarities between the two. The processes are identical with some parts of it. So you go back, and I'm going to just go back to the top one. It doesn't matter which one you use, but the top one seems easier to deal with. So I'm going to get 2 plus y equal 1. See, that's a negative, so most students prefer to use equations where all the variables are positive. All the coefficients of the variables are positive, and your constant is positive as well. But it does not matter which one you use. So 2 plus y equal 1. 2x is 2. So I solve this equation for y. So subtract 2 from both sides, combine like terms, I get y equal negative 1. And so there's your other coordinate. All right. Now just like before, just like when you solved for x and y, you checked. So make sure you check your solutions. So let's check. So when I check, you got to go back to both of those. So you got to check to make sure it works in both of them, because you could have made a mistake. All right, so let's check the first one. So x plus y equal 1. So in place of x, I plug in 2. In place of y, I plug in negative 1. So 2 plus y, which is negative 1. And the question is that the same? So it's yes, because that's 1. So that works. We got to do the other one too. It's got to check both of them. X minus y equal 3. So x is 2, y is negative 1. So is 2 subtract a negative 1 the same thing as 3? That's the question. Well, remember, subtracting negative 1 means the same thing as adding the opposite. So it's 2 plus 1. And so, yes, it does work. 2 plus 1 is 3. All right, so your solution is x equal 2, y equal negative 1. As an ordered pair, it would be 2 comma negative 1. So that's your solution. Okay, now, remember, though, this was easy. This was easy because right away I added them. The variable y was eliminated. All right, now, Let me explain why the variable y was eliminated. Let's ask ourselves, well, why was the y eliminated? Well, remember, when I combine like terms, the y's were eliminated because this coefficient and this coefficient were opposites of each other. Notice I'm using the word opposites. Opposites. Positive 1, negative 1. If this was a positive 6, I'd want this to be a negative 6. If this was a positive 9, I want this to be a negative 9 because a positive 9 and a negative 9 is 0. All right, so through our discussion, when we go through using the addition method, we're going to use the word opposites. I need these to be opposites. Okay? That's the only way when I add them, they'll be eliminated. Okay, so before you add them, before you add these two equations, you got to make sure that the variable that's being eliminated, the coefficients are opposites. Coefficients are opposites. Okay, so let's look at this one. Number 2. So let's suppose we had 2x plus 3y equals 6, and then 2x minus 3y equal 6. So let's suppose we had that. Okay, so the question to you becomes this. Can I add those equations right away? And the answer is yes. Because if you look at the y's, the coefficient of y's are opposites of each other. A positive 3 and a negative 3. So when I add those, I get 0 for y. So 2x plus 2x is 4x, so I can add these. So 2x plus 2x is 4x. This is 0, equal 6 and 6 is 12. And notice I went from, notice I now have an equation with just one variable, so I can solve for x. So divide both sides by 4. 4 divided by 4 is 1. 1 times x is x, equal, and then 12 divided by 4 is 3. So I found my x coordinate. So far my solution is x equal 3. Just like with substitution. Remember, always go back to your substitution to review this. But just like substitution, when I noticed I had a linear equation with just one variable, I solved for x, then I back substituted. I went back and I substituted for y. Okay? So the same thing is going to happen here. So I found the x, which is 3. I'm going to go back to one of these equations, and I'm going to plug in 3 for x and solve for y. All right, so it doesn't matter which one you use. I'm going to use this one since the coefficients were positive. It doesn't matter which one you use. At some point, you're going to have to divide by negative 3. Let me just go ahead and do this and just show you what to do, just in case you do use this one, just to show you. So we're going to get, so I got to find y. So I'm going to use 2x minus 3y equal 6. Okay, so I get 2 times x is 3. So notice 2 times x is 3, minus 3 times y equal 6. 2 times 3 is 6, so I get 6 minus 3y equals 6. All right, so I got to get y by itself. So I'm going to subtract 6 from both sides, just like this. 6 subtract 6 is 0. 0 minus 3y is a negative 3y. Make sure you say negative 3y equal, and then 6 minus 6 is 0. I can get y by itself. To get y by itself, you divide both sides by negative 3. Negative 3 divided by negative 3 is 1. 1 times y is y. And you got to know that 0 divided by negative 3 is 0. All right, so I found my y coordinate. So my y coordinate is 0. All right, so my solution would be, as an ordered pair, it would be 3, 0. Now, let's check. Always check. Always check. Go back. Remember, you got to go back to the original. So 2x plus 3y equals 6. 2x minus 3y equals 6. So in place of x, I plug in 3. In place of y, I plug in 0. So let's see what we get. Let's do this one first. 2x plus 3y equals 6. So x is 3, I'm saying. So that's 2 times 3 plus 3 times 0. Y is 0. And we'll see if that's equal to 6. Well, 2 times 3 is 6. 3 times 0 is 0. So is 6 plus z equal to 6? The answer is yes. Okay, let's do this one. 2x minus 3y equal 6. So again, x is 3. So 2 times 3 minus 3 times 0. And we'll see if that's equal to 6. That's the question. 2 times 3 is 6. 6, a negative 3 times 0 is 0. So minus 0 plus 0 doesn't matter. And so is that equal to 6? The answer is yes. All right, so 3 zeros are your solution. All right, let's look at this one. All right, let's suppose we had this. We had x plus 2y equal 2, and then negative 4x plus 3y equal 25. All right, so x plus 2y equal 2, negative 4x plus 3y equal 25. All right, now remember in the previous two, I added right away because I noticed that one of the variables, in this case the y's, had coefficients that were opposites of each other. So I could have added right away. And then it makes things a lot easier. All right, so here, adding right away is not going to help because x and a negative 4x is a negative 3x, 2y and 3y is 5y. None of the variables were eliminated. So the idea is to eliminate one of the variables. Okay, so here's the idea. So if you look at this, the variable that was eliminated, the y, look at the characteristics of it. The variable that was eliminated, in this case the y, one coefficient was positive, the other one's negative, and the coefficients themselves were opposites of each other, positive 3, negative 3. All right, so over here, be strategic. So it does not matter which variable you eliminate, does not matter, but I've got to somehow have these coefficients, either the x's or the y's, opposites of each other. It does not matter which one though, but they have to be opposites of each other. All right, so let's look at the steps. So here's the steps you're going to perform. Okay, so, all right. So if necessary, first thing, step 1, if necessary, rewrite both equations in the form ax plus by equals c. Now remember, that's called standard form. So if you look at your system, it is already in standard form. All the variables on one side, all the constants on the other. And also, you need to make sure that your variables are aligned. The x's are under each other, and the y's are aligned as well. Okay, so it is already in standard form. So that was step 1. Step 2, if necessary, multiply either equation or both equations, so one or the other, you may have to do both, by appropriate numbers, non-zero numbers, so that the sum of the x coefficients or the sum of the y coefficients is 0. All right, so listen to what this means. You have to determine which variable you want to eliminate. Okay, so it does not matter which one, if you want to eliminate the x or the y. So I'll do both just to show you. So if I want to eliminate the x's, suppose you want to eliminate the x's. All right, so that would be step 2. We're working on step 2 right now. Working step 2. If I want to eliminate the x's, now remember that means that one's positive, one's negative, which it already is, positive, negative. But I got to make sure that the coefficients of the x's are opposites of each other. All right, so here's how you determine that. This is a 1, this is a negative 4. So you got to find, first of all, find the LCD of 1 and negative 4. So the LCD of 1 and negative 4 is 4. So the LCD of 1 and negative 4 is 4. All right, so what that means is this. You want the coefficients of x's to be a 4 and a negative 4. That's what that means. You want the coefficient of x to be a 4 and negative 4, and then to eliminate. Well, this is already a negative 4, so I need this to be a positive 4. Okay? But remember, if I multiply this by 4, then I've got to multiply both sides by 4. All right, so still doing step 2. So I found the LCD of the x's. That was 4. So I need the coefficients of the x's to be a positive 4 and a negative 4. This is already negative 4, so I don't do anything with it. But I need this equation to have x to be a positive 4. So what you're going to do is this. So I'm going to go ahead and rewrite this just to show you. X plus 2y equal 2, negative 4x plus 3y equal 25. All right, so listen carefully. So here's what you're going to do. You're going to multiply both sides of that equation, everything in that equation, by 4. And then you can distribute. You can distribute. And so basically, remember you got to do every term, both sides. Multiply this by 4, multiply this by 4. So now we get this. So now we get this equation. 4 times x is 4x. 4 times 2y is 8y. Equal, and then 4 times 2 is 8. So got to make sure, though, you do both sides. A lot of students forget about this, the constant. You got to multiply everything by 4. So I wrote a new equation, but still equivalent. It's equivalent to this one, but it's a new equation. Now I didn't do anything with this one because I already had a negative 4. So negative 4x plus 3y equal 25. All right. Now, you remember in the previous problem where I went and I added right away because the y's were opposites of each other? So now ask yourself, remember you want to limit the x's, so are the x's opposite of each other? And the answer is yes. So now, step 3 says now you add. So now I'm going to add. So when I add now, so notice before I added right away, so I didn't have to do a step 1 and a step 2. In this one, I had to do a step 2. Step 1 was already there. Step 1, remember, standard form. So I had to do a step 2. Now I'm ready for step 3. So step 3 is to add. Okay, when I add, these cancel out. Those are eliminated. And the 8y plus 3y is 11y. 8 and 25 is 33. And then notice I have an equation with just one variable, a linear equation. So now solving for y, divide both sides by 11. 11 divided by 11 is 1. 1 times y is y, equal 33 divided by 3 is 3. So I've found so far my solution, y equals 3. So now I've got to find x, and that's step 4. So step 4 is to find the value of x. So remember, that's why you back substitute. That same phrase again. So you're going to go back to one of these original equations. Go back to your original system, not any of these because you could have messed up. Go back to the original. And in place of y, you plug in 3. Now again, choose one that looks simpler to use. So hopefully you recognize that this one looks like the easier one to use. It looks less complicated than this one. But again, it does not matter, but be strategic. Use this one. So step 4 then is you're going to substitute y equal 3 into one of the equations. And then solve for x. All right, so I'm going to pick the first one. So x plus 2y equal 2. So I'm just using the first one. All right, so in place of y, I'm plugging 3. So I get x plus 2 times y, which is 3, equal 2. So this is 6, so x plus 6 equal 2. Subtract 6 from both sides. Combine like terms. I get x to be negative 4. So I found my solution. So my solution is y equal 3, x equal negative 4. So as an ordered pair, it will be negative 4, comma 3. So xy. All right, now again, I could have made a mistake anywhere along the way, so I got to check. So let's see, so step 5 is to, so step 3 was to add the two equations, and then step 4 is you solve. And then this is step 5, using our steps here. And then step 6 would be to check. So step 6 is to check. All right, so let's check. So I'll go back to the original system, and you check them. So we'll go ahead and rewrite it. So x plus 2y equal 2. Negative 4x plus 3y equal 25. And so let's check this one. So x plus 2y equal 2. So in place of x, I plug in negative 4, and in place of y, I plug in 3. So negative 4 plus 2 times 3, I want to see if that's equal to a 2. So negative 4 plus, and that's 6, and so yes, that is equal to a 2. So it does work out. Now let's check this one. Negative 4x plus 3y equal 25. So again, x is negative 4, y is 3. So it's negative 4 times negative 4 plus 3 times 3, the same thing as 25. That's the question. Well, that's 16, that's 9, and so yes, 16 plus 9 is equal to 25. So this is correct. All right, so notice the steps. Notice the steps. All right, let's look at another one. So this is number 4. All right, suppose number 4 we had this. Let's suppose we had 4x plus 3y equal 15, and then 2x minus 5y equal 1. Okay, so first of all, step 1, you got to make sure that both equations are in standard form. Make sure both equations are in standard form. All right, and that your variables are aligned. Okay, so remember, we're doing this by the addition method. So is adding going to help right away? So ask yourself, I add these right away. Is that going to help? 4x plus 2x is 6x. So that variable didn't eliminate. 3y negative 5y is negative 2y. So no, it's not going to help me right away because none of the variables were eliminated. All right, so now we got to go to step 2. We got to do something so that way I can eliminate the variable. So again, pick a variable you want to eliminate. It does not matter which one. Does not matter which one. If you want to eliminate the y, actually let's eliminate the x's again. Let's just eliminate the x's just to show you. Now, a lot of students would eliminate the y because that's already a positive, that's already a negative. Okay, so I'm going to go ahead and do both approaches for this one. So let me go ahead and eliminate the x's first. So let's eliminate. So step 2. So remember, step 2 is you want to multiply either equation or both equations by appropriate numbers so that the sum of the x coefficients or the sum of the y coefficients is 0. So what that means is this. I want, if I eliminate the x's, I need these to be opposites of each other. So you can, first of all, what you need to do is ask yourself, what is the LCD of 4 and 2? LCD of 4 and 2 is 4. So now what I need is that this is already a 4. I need this to be a 4, but the opposite. So I need this to be a negative 4. Okay? All right, so I'm going to go ahead and rewrite this. 4x plus 3y equal 15. 2x minus 5y equal 1. All right, so I need this right here. Remember, I'm trying to eliminate the x's, so I need these to be opposites. So the LCD is 4, so that's already a 4. So I'm going to leave this alone, but I need this to be a negative 4. So I got to multiply this by a negative 2. Okay, notice negative 2. So you can multiply both sides by negative 2. That's the only way you can get a negative 4. All right, so now you're going to distribute. So I'm going to get 4x plus 3y equal 15, and then distribute both sides. Remember, the left side and the right side. Negative 2 times 2x is negative 4x, which is what you wanted. Those are now opposites. Be careful when you multiply. Make sure you don't make any errors along the way. Negative 2 times a negative 5y is a positive 10y equal a negative 2 times a positive 1 is a negative 2. So again, always check to make sure you didn't make any errors. Now, step 3, once I see that those are opposites, now step 3 is to add them. So now let's add them. So when I add them, I'm going to get, this is 0. I get 3y and 10y is 13y. 15 and negative 2 is a positive 13. All right, so I added them. Step 4 is to solve the equation. Solve the equation. So I get 13y equal 13, divide by 13. I get y to be 1. So far my solution, and I always go through that process. So now I know one part of my solution. My solution, y equal 1, I just got to find x. So I need to know what x is. So that's where you back substitute. So step 5 is to back substitute. So you're going to substitute y equal 1 into one of these equations up here. Does not matter which one. So now we're going to substitute. So we got to find x. We got to find x. So I'm going to substitute y equal 1 into one of the equations. Okay. So it doesn't matter which one. I'm going to go ahead and let's go ahead and use this one. Let's use this one. It doesn't matter which one. Let's use this one. So 2x minus 5y equal 1. So I'm going to use 2x minus 5y equal 1. So in place of y, I'm going to plug in 1. So let's see what we get. 2x minus 5 times y remember is 1, equal 1. So I got to solve for x. So 2x minus 5 equal 1. Negative 5 times 1 is negative 5. Adding 5 to both sides. Remember, this is a linear equation, so variables one side, constants the other. So I get 2x equals 6, and divide both sides by 2. I get x to be 3. So the other coordinate is 3. So in terms of an ordered pair, your solution is 3, 1. 3, 1. All right. Now, again, you could have made a mistake somewhere, so make sure you always check this. So check your solution. So let's check. So step 6 is to check. And you got to go back to your original. So my original system was this. 4x plus 3y equal 15. 2x minus 5y equal 1. So let's check the first equation. First equation. 4x plus 3y equal 15. So in place of x, I plug in 3. In place of y, I'll plug in 1. So 4 times 3 plus 3 times 1. And the question is that equal to 15? Well, that's 12. That's 3. And so, yes, that is equal to 15. Let's do this one. 2x minus 5y equal 1. That's the question. So is that equal to 1? Well, again, x is 3, y is 1. So 2 times 3 minus 5 times 1. And I want to see if that's equal to 1. Well, that's 6. That's 5. So 6 minus 5 is equal to 1. So 3, 1 is your solution. All right. Number 5. I'm going to do the same problem. Let's do the same problem. So we'll put a 5 star. Same problem. And remember, in step 2, we eliminated the x. So let's suppose someone else wanted to eliminate the y. So let's say step 2 here, let's eliminate the y first. So adding them is not going to help me right away because none of the variables disappear. So let's eliminate the y. And eliminate the y. So this is already a positive, it's already a negative. So again, you got to find the LCD of 3 and 5. So the LCD of 3 and 5. So the LCD of 3 and 5 is 15. Okay? All right, so what that means is this. I need both of those to be 15. So one's going to be a positive 15, the other's going to be a negative 15. That's what that means. So once I've get these coefficients right here to be opposites, then I can add them up. So I'm going to go ahead, I'm going to rewrite this. 4x plus 3y equal 15. 2x minus 5y equal 1. All right, so these one's already positive, one's already negative. So all I got to do, see in the previous problem, I had to multiply by -2. The only reason I had to multiply by -2 is because both of those had the same sign. So this was already a positive 4, so I needed to have this to be a negative 4. In order to get a negative 4, I had to multiply by -2. Over here, the signs are different. So when I multiply this equation and I need this to be a 15, I just got to multiply by 3. But then I also have to make sure that's a 15 as well. So I got to multiply, I'm sorry, not 3, but 5, excuse me. 5. 5 times 3 is 15. But then I got to multiply this by 3 to make that a negative 15. So I'm going to multiply this equation by 5 and this equation by 3. So remember, step 2 said said multiply either equation or both. So in this case, I had to do both. When I just eliminated the x's, I just had to do one. I just have to multiply one equation by -2. Here, I got to multiply both equations by a number. Okay, now distribute. So notice what's going to happen. Remember both sides. Don't forget both sides. Some students forget both sides. Okay, so I get the new system, which is equivalent to this one. 5 times 4x is 20x. Now you got to be careful on the way. You could easily mess up. 5 times 3y is 15y. Equal 5 times 15. I think I said 5 times 3y is 15y. And then 5 times 15 is 75. Okay, 3 times 2x is 6x. 3 times a -5y is a -15y. Equal, and then 3 times 1 is 3. Okay, so that's where we're at. Now we can add. So step 3 is to add. So when I add them, I get 26x. This is 0. Equal 78. All right, dividing. Okay, now step 4 is to solve. Solve for, in this case, the variable x. Solve for x. Solve for x. So I'm going to go ahead and divide both sides by 26. And so x should be 3. X is 3. 78 divided by 26 is 3. So now, so far, my solution, I have x equal 3. All right, now all you do now is you got to go back. You're going to back substitute, and in place of x into one of these equations, doesn't matter which one, in place of x, I'm going to plug in 3. Now remember, when we did this one, remember we did get x to be 3, but it was at a further part. Okay, now I got to solve for y. So step 5 is where we got to find y. So step 5 is where we find y. So we're going to substitute, what we're doing is we're going to substitute x equals 3 into one of these equations. It does not matter which one. If you want to use the second one again, that's fine. It does not matter. So let's do the second one. 2x minus 5y equal 1. Okay, so here we go. So 2 times x is 3, minus 5 times y equal 1. This is 6. I get 6 minus 5y equal 1. Subtract 6 from both sides. 6 minus 6 is 0. 0 minus 5y is a negative 5y. Equal 1 minus 6 is -5. And then to get y by itself, I divide both sides by -5. -5 divided by -5 is 1. 1 times y is y. So I get y to be 1. And -5 divided by -5 is 1. And so my y solution, the y coordinate of my solution is 1. So as an ordered pair, it's 3, 1. Okay, and then remember step 6 is to check, but we already did that. We already checked. Step 6 is to check. Okay, let's look at this one. So there are times, just be aware, there are times when you just got to multiply one equation by a number before you add, and there are times when you will have to multiply both sides of an equation by a number before you add them to eliminate. All right, let's look at number 6. All right, suppose number 6 you had this. Let's suppose we had, let's see. Okay, let's suppose you had this one. 3x plus 2y equal -6. 2x equal 7 minus 5y. All right, suppose we had that. Okay, well, remember step 1, you got to remember this. Step 1, you got to make sure both equations are in standard form. So the first equation is in standard form, but the second one is not. So I got to rewrite this. So step 1, you got to put it in standard form. So in the previous 5, they were already in standard form. This one's not. And remember, when putting in standard form, make sure your variables are aligned. Okay, so I'm going to get 3x plus 2y equals -6. So this was already in standard form. This one's not, so I'm going to have to add 5y to both sides. So bring the negative 5y over by adding 5y to both sides. So I get 2x plus 5y equal 7. Okay, so first of all, you have to put in standard form. All right, now, step 2. So step 2 is where you think about, well, what is it, which variable do I want to eliminate? It does not matter which variable you want to eliminate. Do you want to eliminate the x or eliminate the y? It's up to you. So if you want to eliminate the y, let's say, then you got to look at what the coefficients are at this point. So the coefficients are 2 and 5. So we got to find the LCD of 2 and 5, and the LCD of 2 and 5 is 10. Okay? Now remember, before the idea of adding, when you add these equations, these have to be opposite. So if you want to eliminate the y, that means when you add them, the better cancel out. So that means that these coefficients have to be opposite. So one has to be positive, the other one has to be negative. Okay? All right. So we're gonna multiply, and let me go ahead and rewrite this. 3x plus 2y equal negative 6. 2x plus 5y equals 7. All right. Now, remember, that's where we're going to multiply these equations by a number, so that way one's 10, one's a negative 10. Okay, so let's now remember, you got to do both this time. Hopefully you see why you have to do both, because none of them is 10 or negative 10. They're 2 and 5. Okay, so it's up to you. Do you want to multiply the first equation? Remember, I have to multiply 2 by 5 to get 10. Here I've got to multiply by 2. So in other words, you have this so far. I got to multiply this by 5 and this by 2. Hopefully you see that. Because 5 times 2 is 2y is 10y. 2 times 5y is 10y. But one of them has to be negative. Because remember, before I can eliminate them, they have to be opposite of each other. So you determine, do you want this one to be negative or this to be negative? It does not matter. It does not matter at all. So if you want this 2 to be negative, that's fine. All right, so let's go ahead and rewrite it. To make sure you multiply everything by 5, make sure you multiply everything by negative 2. So 5 times 3x is 15x. 5 times 2y is 10y. That's 10y. Equal. 5 times negative 6 is negative 30. So make sure you do everything. Common mistake is to forget about the constant. Okay? The next one. Negative 2x times 2x is negative 4x. Negative 2 times 5y is negative 10y. Equal. Negative 2 times 7 is negative 14. And now, step 3 is to add. So when I add 15x and a negative 4x is 11x. The y's cancel out, and that's going to equal a negative 44. So I get 11x equal negative 44. So now I have this equation with just one variable. So now step 4 is to solve this equation. So I have 11x equal negative 44. So dividing both sides by 11. 11 divided by 11 is 1. 1 times x is x, equal, and that's a negative 4. Negative 44 divided by 11 is a negative 4. So far my solution to the system, x equal negative 4. Now step 5 is where you have to find y. So that's where we back substitute. So I'm going to substitute x equal negative 4 into, and you just choose one of these equations. It does not matter which one. We're trying to, what I would do, see how I'm trying to find y? I'm trying to find y. I would not use this one. I mean, you could. It does not matter. It does not matter. But I'm just going to go ahead and use the first equation. So I'm going to get, so substitute into 3x plus 2y equal negative 6. All right, so in place of x, I'll plug in negative 4. So I get 3 times negative 4 plus 2y equal negative 6. 3 times negative 4 is negative 12 plus 2y equal negative 6. remember, we got to get y by itself. So adding 12 to both sides. Negative 12 and a positive 12 is 0. So I get 2y equal. Negative 6 and a positive 12 is a positive 6. Solving for y, dividing both sides by 2. 2 divided by 2 is 1. 1 times y is y. So we get y to be 3. So my y coordinate is 3. So as an ordered pair, your solution is negative 4 comma 3. All right, now again, step 6 is where you're going to check. Okay, you're going to check, and you've got to go back to the original. Oops, sorry. You've got to go back to the original to check. All right, so here was the original. 3x plus 2y equal negative 6. 2x equal 7 minus 5y. All right, so let's check the first one. So my first equation was 3x plus 2y equal negative 6. So in place of x, I'll plug in negative 4. In place of y, I'll plug in 3. So let's see what we get. So 3 times negative 4 plus 2 times 3, and I want to see if that's going to equal negative 6. Well, 3 times negative 4 is negative 12, plus 2 times 3 is 6, and so yes, negative 12 plus 6 is equal to negative 6. Okay, let's do this one. 2x equals 7 minus 5y, and in place of x, I plug in negative 4. In place of y, I plug in 3. So 2 times negative 4, and I want to see if that's going to equal 7 minus 5 times y. Y is 3. Well, 2 times negative 4 is negative 8. So again, let's see if if those two sides are equal to each other. So that's 7 minus 15, and 7 minus 15 is a negative 8. So that works. All right. Now, before I go on, I just want to mention, remember when for step 5 I said you can substitute x equal negative 4 into one of these? All right. And if you wanted to do this one, that's fine. Let me just show you what happens if you do it, just to show you. So in step 4, if you had substituted x equal negative 4 into 2x equal 7 minus 5y, you should still get y to be 3. All right, let's check it. So 2 times x is negative 4, equals 7 minus 5y. So 2 times negative 4 is negative 8, equals 7 minus 5y. Remember, we got to get y by itself. So I'm going to subtract 7 from both sides. So negative 8 and negative 7 is a negative 15 equal. This is 0. You're left with negative 5y. And now dividing both sides by negative 5. Negative 5 divided by negative 5 is 1. 1 times y is y equal 3. So again, it did not matter. The whole point here is just to show you it did not matter for step 5. When you substitute, it does not matter which equation you use. It does not matter. You'll still get the same value for the variable. In this case, the variable y was equal to 3. Okay, let's do one more with this. So let's say number 7. Okay, so number 7, let's suppose we had this equation. 5x minus 3y equal 1, and then 3x plus 2y equal 7. Let's suppose we have that. All right, make sure I didn't do it already. Okay, so we're good. Okay, so again, you got to determine which ones you want to eliminate. Okay, do you want to eliminate the x's or the y's? Because adding right away is not going to help. See, when you add them, none of the variables disappear. None of those coefficients are opposites of each other. So you determine, do you want to eliminate the x or the y's? A lot of students, when they see one's negative, one's positive, they're going to eliminate that variable. So let's eliminate the y's. So be strategic. Oh, and first of all, make sure it's in standard form. It already is. Okay, so it's already in standard form. So it's got to align your variables. Okay, so step 2, let's go ahead and eliminate y. And so then what I got to do is I got to find the LCD of 3 and 2. And so the LCD of 3 and 2 is 6. Okay, it's 6. The LCD of 3 and 2 is 6. All right, so what that means, I'm going to go ahead and rewrite this. 5x minus 3y equal 1. 3x plus 2y equals 7. So what that means is that I've got to multiply, since none of these are 6's, I've got to multiply both equations by a number. So 3, I need this to be a 6. So 3 times what is 6? Well, that's going to be a 2. I need this to be a 6. So 2 times what is 6? So it's 3. So I'm going to multiply this by 3. Now the question is, do I need to make one of those negative? The answer is no, because the one's negative, one's already positive. So when I multiply by 2 and multiply by 3, they will already be opposites. Okay, so let's distribute. Don't forget to multiply both sides. All right, so when I do that, 2 times 5x is 10x. 2 times a negative 3y is a negative 6y. 2 times 1 is 2. The next one, 3 times 3x is 9x. 3 times 2y is 6y. And then 3 times 7 is 21. And so I got to make sure, let's see, I'm not sure if this is, okay, it's fine, let's just deal with this. Okay, I think I made an error somewhere in here, but that's okay. Let's see what we get. Okay, so when I add them now, that's step 5. Oops, I said step 4, that's step 2. This is step 3. So step 3 is to add now. So when I add, I get 19x equal, and I think one of these had to be negative. That was the issue. I forgot. Let's make this right here, because I want these to be integers. So let's just make one of these negative. Let's make this right here negative. Just go back and fix it. Negative, negative. So this would be negative 2. All right, so 19x is going to equal, and this is just 19. Okay, so when I divide both sides, now step 4 is to solve this equation. So when I divide both sides by 19, I get x to be 1. So one of my solutions is, solution is x equal 1. So I got to find y. So step 5 is where you're going to substitute. So you're going to back substitute. So you're going to substitute x equal 1 into. Now remember, I went back and I changed this negative 1 because I wanted this to be an integer. So I'm going to substitute x equal 1 into one of these equations. Again, it does not matter which one. Let's use the first one. So 5x minus 3y equal negative 1. So in place of x, I'm going to plug in 1. So I get 5 times 1 minus 3y equal negative 1. 5 times 1 is 5 minus 3y equal negative 1. Solving for y, I'm going to subtract 5 from both sides. So that's 0. 5 minus 5 is 0. I'm left with negative 3y equal negative 6. And remember, to get y by itself, right now I'm multiplying by negative 3. The opposite of multiplying by negative 3 is to divide by negative 3. And so negative 3 divided by negative 3 is 1. 1 times y is y. And I get a negative divided by negative is a positive. 6 divided by 3 is 2. I get y to be 2. So that is the y coordinate of my solution. So as an ordered pair, your solution is 1, 2. 1, 2. All right, now again, I could have made a mistake somewhere along the way, so let's check. So step 6 is to check. So go back to the original. Always go back to the original. So I get 5x minus 3y equal negative 1. 3x plus 2y. 3x plus 2y equal 7. All right, let's check the first equation. So 5x minus 3y equal negative 1. So in place of x, I plug in 1. In place of y, I plug in 2. So 5 times 1 minus 3 times 2. And the question is that equal to a negative 1? That's a question. Well, that's 5. That's minus 6. And so yes, 5 minus 6 is equal to negative 1. Let's check the second equation. 3x plus 2y equal 7. So again, x is 1, y is 2. So it's 3 times 1 plus 2 times 2, let's say equal to a 7. So that's 3, that's 4, and yes, they are equal. So 1, 2 is a solution to this system. Okay, so that's going to take care of using the addition method. It, one thing you got to remember, though, and we only did one like this. See right here, it was not in standard form, so always check to make sure it's in standard form first. All the x's have to be aligned, all the y's have to be aligned on one side, and your constants on the other. So in this case, it wasn't. That's the only one we did where we had to actually put it in standard form. All right, and also keep in mind that in some situations, you're going to multiply both equations by a number, and in some situations, it's going to be 1. And sometimes one of these numbers you multiply by will have to be negative and the other one will have to be positive. Remember, the whole idea is to make whatever variable you eliminate, the whole idea is to make the coefficients opposites. Okay? And then when you add them up, that variable no longer is there. Okay, so that takes care of solving the system by the addition method.